So it's a real pleasure to be here. Thank you to Martin and thank you to EPFL. And it's a real pleasure to know that I'm going to be followed by Debussy. Okay, I love Debussy. L'Huile Joyeuse is a wonderful piece. And I'm sure there's a joke there about going from the ridiculous to the sublime, but I'm not going to make it. So I should acknowledge some colleagues who work on the Nature journals who've really helped our thinking and our implementation, and also other publishers. You've seen how we're all in the business of evolving, innovating, and so we're all doing that. This talk is more my personal view about a content-driven approach and motivation for openness rather than the business. I will say a tiny little bit about the business, but it's not my responsibility, and other people in our company are more qualified to talk about it. My roles include overseeing the cross-company editorial policies and standards, so issues like reproducibility come in there, and then developing cross-company initiatives directed at the Sustainable Development Goals in particular, and I'll say more about that towards the end of the talk. But these are content initiatives, these are not business initiatives. And the talk reflects on openness as seen through these particular perspectives. So I will talk about OA principles from the publisher's point of view, but I'll be focusing on integrity and the relationship between that and openness, disaggregation of the research content, the research object, and we've heard a bit about that, multidisciplinarity and multi-sector openness. I'll give an example of the need for that, and that is a driver both for openness and for cultural change. A lot of what's going on here is reflected also in the need in universities, supported by funding agencies, to change their cultures. And I wanted to say something about that. And a little bit towards the end about the rise of the machines, and then the moral of the tale. So Springer Nature and open access models, I'm just going to make a very straightforward statement that, and this comes from the company, this is not so much my statement. So Springer Nature is committed to a future of full and immediate open access. Green open access, which, for example, all the Nature journals, with the exception of Nature Communications, all the Nature journals are green. That is only for the transition. And during the transition, Springer Nature intends to highlight the benefits of open access, full open access, both prospectively in terms of promoting it as a way of submitting, and also retrospectively by showing on papers the difference between, for example, the citation rates and so on. So that's something we want to be more proactive about. And that is something which the Chief Publishing Officer, Stephen Inchcombe, who I report to, has really made a task for himself. He's much engaged with the Plan S group and universities and funding agencies to really see how we work through that transition. And that's a blog that he did, that if you want to find out about the specific proposals he's been making in terms of transformative journals, as he calls them, you'll find them all there. So now I wanted to get on to the content stuff and looking at open components of research and how to promote them. And you've seen a bit of this already, and I'm not going to spend a lot of time on it. Data, everyone talks about data. I'm particularly proud, I have to say, not that I had any role in it, in our publication, Scientific Data. And the reason I like that is that it gives data credit where it's due. It highlights not the data itself in its content, but it gives data descriptors so that the people who actually generated a data set that has its own intrinsic value, regardless of the publications that relate to it, actually can describe it properly, show where it can be got, and get the credit for it. But then there are all these other ways of hosting data, and what we do, among other things, is to make it absolutely compulsory, in some of our journals, not all, but in some of our journals, compulsory to show where the data are. Sometimes we host them ourselves, as you saw with EMBO. Sometimes we have other people hosting it in a way that makes it directly accessible from the paper, or we just make it clear to readers where they can get the data. So that is something we all want to do in the publishing world because it's so obviously what needs to happen. Code sharing, you heard from the IEEE about CodeOcean and one or two other platforms where people are trying to host, well, they are hosting software that actually can be run on the platform so that, in principle, a reader of the paper can go to the platform and run the model in the paper with their own parameters. And that, I think, is really important and a real plus for the world. So that's something we're very much encouraging too. Open research components, that is the components of the research, reproducibility. So reproducibility includes so many different elements that it's 5 talks in itself. The thing that really got me fired up about reproducibility was this paper. I was at the time a trustee of a big charity in the UK, Cancer Research UK, and we were having a board meeting, and that very day that issue of Nature had come out, and this was in it. And I was actually reading it for the first time at the board meeting. I shouldn't have been, but I was. And here it was, a description of the shoddiness of a lot of what was being published in cancer research. And it became clear how much responsibility we as journals had for that, as well as the labs. So a big effort began. And as far as we are concerned, we started to do things like bringing in a checklist, reducing length limits, or I'm sorry, not reducing, completely abandoning length limits on our method sections, raising standards for the reporting of statistics and the scrutiny of that during peer review, and encouraging protocols. So we did quite a lot of stuff ourselves. We joined with other journals in encouraging this sort of stuff, and so that has turned into a community movement, which I'll describe in a minute. But we also did some work on the impact of this checklist and other measures on what went into the papers, and a lot of authors that we surveyed showed that the checklist had a really positive experience for them, even though it required work. And similarly, people started using the checklist knowing that it was going to be required of them to make sure that it was clear to the reader of the paper, but also in the way they designed their experiments, what it was that they had done and what it was that they hadn't done. So if they hadn't done randomization, for example, you don't always need to do randomization, but sometimes it really adds value to the rigor of the study if you do, but we don't insist on it as long as you declare that you haven't done it, so to make it clear what the strengths and weaknesses of the reproducibility are. So this is the sort of thing where there clearly was, as a result of the sort of policies that we and others were introducing, a community shift. Okay, then this collaboration started in December 2017. So there are many, many instances where publishers get together to develop standards that are of common benefit to the research community. And this was one of them, looking at how do you make sure that other journals, beyond those who were being pioneering about that reporting of transparency, can actually develop and improve their own performance. So these were the publishers who were all involved and some of the experts in reproducibility. They came out with a draft framework and a checklist, plus results of pilot tests involving about 30 journals. And they're just about to get public with that to actually encourage further consultation. And then the final publication, as they envisage it, will be in early 2020. This is above all for the life sciences community, because there are so many aspects of dealing with complex organisms that require that greater degree of effort to be transparent about what you didn't do. Reproducibility really does take time, and it takes time by editors, which you've just absorbed, and it takes time by researchers to do that extra work. And what I like to say sometimes is that a key goal for, let's say, 10 years from now is that the researchers, whether in the life sciences or in other disciplines, should be publishing half as many papers per research dollar or euro than they're publishing at the moment, because they're being more rigorous in the way they do the work. So that's just a provocative suggestion, but nevertheless, there is something about that. Now, behind these reproducibility problems or irreproducibility problems is a lab culture problem. And in so many labs, the dynamics between a researcher head, the head of a research group, and the people in that group can be problematic. And I'm saying this based on about 20, 25 workshops I did in universities with postdocs, with PIs, especially in the US, but not only in the US, and looking at exactly how the dynamics works and how the incentives work from the system at large, and how in so many cases you can have a tremendously inspiring group leader, but you can also have an inspiring group leader who doesn't really know how to lead, and you can also have people who are truly awful. And the question is, what's the governance of that process? What are the universities doing to encourage a healthy research culture that makes sure that people in the lab have due scrutiny against, for example, data manipulation at the worst, or just cherry picking at the not so good? So these are all things we studied in a particular issue of Nature and an online collection in 2018. Which was a result of all of that engaging with the community about what was right and wrong within the research lab. So the lab culture really matters, and the funders and universities need to be proactive and transparent about how they foster a healthy research culture. And the worst embodiment of things going wrong within the lab are the sheer number of totally rubbish biological images that are sent to publishers. There is no way we can pick these up before publication. Occasionally we can, but the sheer volume of badly manipulated images that should never be getting out of the door is, to me, an indicator of some of the problems. Now, this is very provocative and it's full of generalizations, and I don't want to give the impression that the entire biology community is in crisis, because it certainly isn't. But there are really worrying aspects of that, which only a change of culture can really prevent in the long run, despite everything that the publishers do, which is substantial. Now I want to talk about the shape of the research paper and how that's evolving, and I use the word disaggregation. So obviously, value of preprints. Putting the work into a preprint, we've certainly recognized that from the time I started as the editor-in-chief of Nature, where we made a very clear statement: if you put your paper in archive, which was the only preprint server really active at that time, it doesn't cost you anything from our point of view. Fine, great, you're getting feedback for the community. Now we have bioRxiv, which is growing. And then there are ways in which we actually publicize and help people know that what is in a preprint server is actually also under review at one of our journals. And then we also have something where, and we're not unique in this, where we're being more open about papers that are actually under review, in allowing authors to spread them around the community as they are being reviewed, and also to have a better access to the process of review itself. So a lot of what's happening at the preprint stage is something that we totally value and recognize. Then there is this fundamental question that affects any discipline, actually, where if you're testing a hypothesis and you do the work and you look at it, you look at the data, and you realize, you know something, actually, if the data said that, or if I pick those data rather than those data, my hypothesis can look defendable. But somehow or another, that gets to be a bias because you're so wedded to the hypothesis and you haven't published the hypothesis. So pre-registered reports, which are a perfectly standard means of publication in some disciplines, is being encouraged and is growing, and is something I certainly would like to encourage for certain types of research, not all research. If you're just out there exploring, this isn't what you do. But if you have a particular hypothesis and you're going to publish a paper that tests that hypothesis, you want to first publish the hypothesis itself and how you are going to test it. And you get that peer reviewed. And people who do this say that the peer review process here is really constructive, because people want to help you do a good experiment. So stage one is where you actually have that particular stage of work peer reviewed and published and deposited in an open database. And then stage two is the next stage, where you've actually done the work and you're reporting the results, and then you can relate back to what you said originally, and so can the referees and editors, and you can see just how good the piece of work is and how good it is at validating the original hypothesis. So this is just an example, and I'm tempted to look at the title and read the paper, because I actually haven't. Exogenous testosterone increases sensitivity to moral norms in moral dilemma judgments. I love that title, and I wish I had time to explore the paper and then discuss it with you all, but nevertheless, there it is. It was an example from Nature Human Behavior, which is leading within our group this sort of publishing. And that's the first stage, where they published it in a database before peer review, with peer review, but before the actual experiments had been done and conclusions drawn, and then here was the final version that appeared recently. So that's just to show the process in action. But interesting is the trend. Stavroula Kusta is the editor of Nature Human Behavior, and she was saying we've received more than 130 stage one submissions since the journal launched. And although our initial submissions were mostly in psychology and neuroscience, we are now receiving submissions from a number of different fields, including genetics, economics, and political science. This suggests that their appeal is increasingly spreading beyond the disciplines where the pre-registration format originated. So I just thought I'd highlight that as an example of how to counter bias in the way scientists think about the results of their work. And multidisciplinarity, of course, everyone pays lip service to this, and when they really pursue it, they find how difficult it is to really do it. We try to do it, and I think we succeed to an extent in some of our journals, which are thematic rather than disciplinary. Nature Climate Change was the first of those, where you have editors within the group internally who are social scientists as well as natural scientists. Nature Energy, Nature Human Behavior, Nature Sustainability are other examples. So the question is, what are we going to publish? And what do we see publishing more? So the UN Sustainable Development Goals, I hope many of you are familiar with these, and they include a whole range of topics, every one of which every academic, not every, but in most cases every academic discipline can say something about. And there's a recent report that I just wanted to highlight as an example of the opportunities and needs for the universities, for the funding agencies, and for publishers to think about. So one of the pictures that's emerged recently from modeling is just how, if you're trying to make the planet a healthier place for us all, the way you do food, the way you consume food, the way you produce it, etc., almost has a disproportionate impact on what you do in terms of the sustainability in what you achieve. This is the Food and Land Use Coalition recent report, which is a massive modeling exercise. It's a very substantial piece of work. And they include in this a diagram which I think really nicely encapsulates the problem of food and the challenge of food. At the top, you've got the healthy diets, which is what you're ending up with. And by health, you include not only individual health, but also planet health. And then you have beneath it the agriculture systems, the protection and restoring of nature itself and the land, the protection and restoring of the oceans. Each of those is a massive area of research and implementation. And what you find when you look at each of them is how important it's not only the engineering and the biology and the whatever, the ecosystem understanding, but also the humanity of it all. That is, what about equity of access to different resources in the oceans? What about crime in the food chains, in the food supply chains? So these are all human issues which are just as important as the technical solutions that we're trying to come up with. So these are truly multidisciplinary, diversifying protein supply, reducing food loss, the local linkages about what happens, for example, within individual cities or rural environments, and then beneath those, you have these bigger issues of gender, where women have a huge role to play, more than they do at the moment, within the supply of food, especially in artisanal enterprises, fisheries, and small farms. And digital revolution, the data that we now have available to actually analyze what's going on. So each of these are big areas where people can fund research, do it in universities, but have to be connected to some of the other interests within it if it's going to be productive. And then finally, from that report, there are these target groups, such as investors. These are the stakeholders in this research. These are the people who we as publishers would seek to influence on behalf of you and on behalf of the funding agencies. And some of us haven't given much thought at all to the investment community as a direct target for what we publish. And one of the things that Martin said at the beginning about the role of the university is about education. And education, of course, internally for the students, but also the wider public engagement and education. And the question for us, we publish Scientific American, we publish Nature. What are the things we should be doing for those audiences, as well as you, the research audiences? I just want to finish by talking, well, nearly finished, with solutions-oriented content types, which deserve more support and prestige. So you produce a paper and you get good marks for your tenure committee or your promotion committee or your applications committee. But there are certain types of non-traditional in some disciplines, completely traditional in others, which I think will become more relevant as we get into things like societal challenges. So the case study is where you write something up that actually happened, who did what. It's not necessarily generalizable. It's not conducted as a scientific experiment. It is just what happened and how you document it. But as a collection of case studies, it can be a real resource. And indeed, each case study can be a resource, but a collection of case studies can be a resource. This is about urban climate solutions, where people are trying to manage the local climate and the microclimates within cities. And this looks at 4,000 case studies that are out there in the literature, collects them and tries to draw some conclusions from them. So that's just an example of that sort of publishing. Expert elicitations, which used to have very low prestige and were not recognized, for example, by Nature and not recognized by the Intergovernmental Panel of Climate Change, and now are, where scientists get into a room and try to use their expertise to form judgments to answer questions that can't be answered just from a review of the literature. And this is an example of something that we published recently in Nature, Climate as a Risk Factor for Armed Conflict, which is quite a controversial topic out there, and this was an expert elicitation. And then systematic reviews, many of you are familiar with these, and interestingly, there's a new database which is a collection of systematic reviews in a whole different range of themes, specifically intended to go beyond the health collections that you find in Cochrane and so on, but going into the topics of all of the SDGs, the themes of all of the SDGs. This is a database, a social systems evidence, which is hosted at McMaster University. And it just seems to be a very notable approach, because they not only host the reviews, but also try to give summaries of them for policymakers. And then my final topic is harvesting the literatures. So obviously, a lot of the time, you as an academic, you've got a job to do, you will search the literature and you'll look for it. And if you're writing a book, for example, you'll have to do a big job before you sit down and write the book. So the question is, how can machines help you? And here's an example that Springer Nature published the first machine-generated book. I think within academia, anyway. I think that science fiction has been generated by a machine, but this was a not particularly compelling book. I'm sure my publicity department won't forgive me for that, but let's be frank, lithium-ion batteries. But it is completely generated. The content was ordered, and the actual content was generated by a machine. And there's it's all freely available, and there is a prologue to the book written by Henning Schönenberger, who is human, and he actually describes how it was produced. So if you want to find out more about that, then do. But the key thing I want to highlight there is not so much the authorship of the book, which is a separate issue, and we are not claiming that this is going to replace humans in terms of authorship. But in terms of getting to the material, a machine can search so much more deeply, so much more broadly, so much outside your own specialist area of knowledge, that it's bound to be helpful to avoid bias, or to mitigate bias anyway. And it's great for the multidisciplinary themes. So we can all see that coming, but I just wanted to highlight that as an example. So what is the moral of all this? Making the literature trustworthy and useful takes more effort and investment by researchers, funders, institutions, and publishers than is currently happening, with results that are less easy to measure and celebrate than hiring yet more postdocs and publishing yet more, sometimes shoddy, papers. And I feel that really strongly, that the amount of effort the research community puts into rigor and usefulness is going to have to shift in those directions against just publishing more and more. So a truism, these are major challenges, and we're all in this together. So I'll finish by saying happy birthday to EPFL, and if I may, happy birthday to us too. Thank you.